For decades, astronomers believed one thing was certain: galaxies spin. But now, the James Webb Space Telescope has discovered something extraordinary: a massive young galaxy that appears to have almost no rotation at all. How is that possible? Has James Webb discovered a rare exception? Or could this change what we know about how galaxies form? Let's travel billions of years into the past to uncover the mystery of the galaxy that doesn't spin. When the James Webb Space Telescope looks into deep space, it isn't just looking across vast distances. It's looking back in time. Because light takes time to travel, every distant object we see appears as it was when its light first began its journey. The farther James Webb looks, the younger the universe becomes. Some of its observations reveal galaxies that formed only a few 100 million years after the Big Bang. These ancient galaxies are more than distant objects. They are snapshots of the universe's earliest history, captured billions of years later. And it was during one of these observations that astronomers noticed something they had never expected to find. The galaxy is known by an unusual name: XMVID 1-2075. It isn't famous because of its appearance. In fact, at first glance, it looks like many other distant galaxies observed by James Webb. But appearances can be deceiving. This galaxy existed when the universe was only about 2 billion years old. Despite its young age, it had already grown into a massive galaxy containing billions of stars. That alone caught astronomers' attention. But the real surprise came when they measured how the galaxy was moving. Astronomers expected to see a familiar pattern. One side of the galaxy should be moving toward us, while the opposite side moves away. This difference allows scientists to measure a galaxy's rotation. It's the same principle used to determine how the Milky Way spins. But when researchers analyzed XMVID 1-2075, the expected signal simply wasn't there. The stars and gas showed almost no large-scale rotational motion. Instead of behaving like a spinning disk, the galaxy appeared strangely motionless. For a galaxy this massive, that was astonishing. This doesn't mean the galaxy is completely frozen. Individual stars still move under the influence of gravity. But unlike most massive galaxies, its overall structure doesn't appear to rotate in the way astronomers expected. That single observation immediately raised new questions. Did this galaxy form differently from every other massive galaxy we've studied? Is it a rare exception, or evidence that the early universe was far more complex than we imagined? Before we can answer those questions, we first need to understand why galaxies spin in the first place. Because without that piece of the puzzle, it's impossible to appreciate just how extraordinary this discovery really is. To understand why this discovery surprised astronomers, we first need to understand how galaxies are born. Everything begins with an enormous cloud of gas and dark matter. Gravity slowly pulls this material inward. At first, the cloud may appear almost motionless. But in the universe, perfect stillness is almost impossible. Even the smallest imbalance creates a tiny amount of motion. As gravity continues pulling the cloud together, that motion becomes stronger. The same thing happens when an ice skater pulls in their arms. Their spin speeds up. Astronomers call this the conservation of angular momentum. It's one of the most fundamental laws of physics. From planets to stars to entire galaxies, it shapes how objects move throughout the universe, which is why astronomers expect nearly every large galaxy to rotate. Rotation isn't unique to galaxies. It's everywhere. Earth spins on its axis. The moon orbits Earth. Earth orbits the sun. The sun itself travels around the center of the Milky Way. Even entire galaxy clusters are constantly moving through space. Across the cosmos, motion is the rule. That's why astronomers rarely ask whether a galaxy rotates. Instead, They ask how fast it rotates. Rotation has become such a normal part of galaxy evolution that discovering one without significant rotation is like finding an ocean without waves. It isn't impossible, but it immediately demands an explanation. But how do astronomers know whether a galaxy is rotating? After all, we can't watch an entire galaxy complete a full turn. That would take hundreds of millions of years. Instead, scientists measure the movement of light itself. As one side of a rotating galaxy moves toward Earth, its light becomes slightly bluer. The opposite side, moving away from us, appears slightly redder. This effect is known as the Doppler shift. By carefully mapping these tiny changes across a galaxy, astronomers can build a detailed picture of its motion. It's one of the most powerful techniques in modern astronomy. And when James Webb applied this method to XMMVID 1-2075, the familiar pattern was missing. By every prediction, XMMVID 1-2075 should have displayed a clear rotational signature. It was already massive. It had formed surprisingly early. And according to our current understanding of galaxy formation, it should have behaved much like other galaxies of its size. Instead, James Webb revealed something unexpected. The galaxy appeared supported not by orderly rotation, but by the random motion of its stars and gas. That discovery doesn't necessarily overturn everything astronomers know, but it does suggest that the earliest galaxies may have evolved along more than one path. And if that's true, our picture of how the first galaxies formed may still be incomplete. Does this discovery rewrite astronomy? Not yet. One unusual galaxy isn't enough to overturn decades of research, but it is enough to make astronomers ask new questions. Is XMMVID 1-2075 simply a rare exception? Or have we only just begun discovering a hidden population of galaxies that evolved differently? James Webb is still exploring the early universe, and every new observation helps complete a much larger puzzle. Astronomers are now searching for more galaxies like XMMVID 1-2075. If similar objects are found, our current models of galaxy formation may need to be expanded. If not, this galaxy could remain one of the rarest discoveries ever made. Either outcome teaches us something new about the universe. The James Webb Space Telescope was built to answer humanity's biggest questions. Instead, it keeps uncovering new mysteries, from unexpectedly massive early galaxies to objects unlike anything astronomers predicted. James Webb is revealing that the young universe was far more complex than we once believed, and its greatest discoveries may still lie ahead. Every time humanity builds a more powerful telescope, the universe surprises us. XMVID 1-2075 may be only one galaxy, but it reminds us that our understanding of the cosmos is still evolving. Some of the biggest discoveries don't answer old questions. They create entirely new ones. And perhaps, that's exactly what makes exploring the universe so extraordinary.